Okay, so this was 6A and we're ready for 6B, and it's dealing with the same chemical reaction. Duplicate this page. No, I guess I'm not. Okay. So anyway, same chemical reaction is at the top of the question. A lot of times in AP we have to look back up the page to find the required information that we need. So here's what it tells us when 50.0 milliliters of a 0.20 molar sodium carbonate solution is added to 100 milliliters of calcium chloride, we end up with a precipitate, 0.855 grams of a precipitate. This means a solid product. So let me flip back a page. So here's what it tells us. We know the concentration and volume of sodium carbonate. We know the volume of calcium chloride, and we know exactly how much solid that we found. So the question is asking us, what is the concentration of the original calcium chloride solution? So this is the way you saw it written on the quiz. It says calcium chloride in brackets equals question mark. And the brackets always means concentration. So this is what the question is asking us for. The first thing to start with, this number right here. So it's a precipitate. It's actually calcium carbonate solid. This is where we have to start. .855 grams of calcium carbonate. And we have to do a few conversions. So the first thing we can do from here is change it to moles. If we're in grams, that's step one. So molar mass, changing it to moles of calcium carbonate. I'll save us some time. The molar mass is 100.09 grams. And there is something that this has in common with calcium chloride. It's that calcium ion. So in terms of this, we're going to say that 1 mole of this calcium carbonate contains 1 mole of the calcium ion. This way it's in terms of ions, it makes it a little easier. So this tells us how many moles of calcium are in this solid product. So we end up with 0.00854, and that's moles of calcium ions right now. Here's something else about the calcium chloride concentration that it's asking for. Concentration of calcium chloride is equal to the concentration of calcium ions, because there's 1 calcium ion for every 1 CaCl2. So here's what we're going to do. Concentration of calcium equals moles over liters. We found moles. Go ahead and put that up here. And what's our volume of the solution? The original solution of calcium chloride?
0.1 liters.
0.1 liters. 1,000 liters. If you look back at the question, it actually says 100 milliliters. So you could have put 100 milliliters and done a conversion. This just saves time and space. So it's 0.1 liters. Which tells us the concentration here is 0.0854 molar calcium, which is also the concentration of calcium chloride.
Why can't you just ignore the chloride? Like, why is that not important?
Because if you look back over here, chloride here is aqueous, and chloride here is aqueous. That makes it a spectator ion, which means that this whole time it was an ion in the beginning, it was an ion in the end.
Okay.
Now, if you want to figure out the chloride concentration, you can. It didn't ask us to do it, but it's just this times 2. So, since I said it out loud, let me write it down. Yeah, and so it's just double this. In general, we ignore spectator ions because they don't give anything. We only care about really the net reaction for this equation. And the net reaction here is that calcium and carbonate made this solid product. I'm only writing it in the middle because I ran out of space. Anyway. This is the net equation, and that's really the important thing of what happened in this equation. Yeah, and actually, this reaction that we're working with here is the same one we were talking about on the first page, and it has both the full balanced equation and the net equation at the top. So anything that is excluded from the net equation, we don't even care. So for number 7, HC2H3O2 aqueous plus NaHCO3 that's solid. Okay. So here's the reaction of what's going on. Now I know we haven't quite finished our ions yet. Actually, barely started. But this one, C2H3O2, has a name. It is acetate. This is acetic acid, vinegar, although probably more concentrated. And that would make this one sodium acetate. This is another polyatomic ion, and it is called bicarbonate. So what we have here is acetic acid plus sodium bicarbonate yields sodium acetate, water, carbon dioxide. Once we get to know our ions a little better, we'll be able to read it a little quicker. Okay. It says calculate the volume of CO2 gas generated when 0.350 grams of sodium bicarbonate is added to excess acetic acid. Let me describe to you what's going on here. We are putting baking soda and vinegar, and it's going to bubble up a bunch, this thing, and then at the end, what we see is a colorless solution with nothing in the bottom because all of the solid was used up. And so we have this solution that is this with probably a little bit extra vinegar. If you put more baking soda in it, it would start up again. So that's a visualization of what's actually happening here. So this is the amount of our sodium bicarbonate we added. It's in grams. First thing is we always have to change to moles. We can't compare two different substances if they're still in grams. Let's see, I've actually got the number here already. 84.01 grams is what we come up with based on your AP periodic table. We are looking for volume of CO2 at STP for this question. So 1 mole of this sodium bicarbonate, right, because the coefficient here is 1. And it makes 1 mole of CO2. Again, the coefficient here would be 1. And so how do we go from moles to volume at STP? There's a very specific thing. Remember, let me write it down here. This is the volume of a gas at STP. Only at STP. Okay? Most AP exam questions are going to be at conditions other than STP, which means not this. But for right now, we can do this. So 0 degrees Celsius, 1 atmosphere, those are the conditions. So just to double check, my grams cancels, my moles of sodium bicarb cancels, my moles of CO2 cancels, and my units are going to be liters of CO2. That's what it's asking me for. Here's the number, 0.0933 liters of CO2. That's A. Part A was at STP. Part B is not at STP. 30 degrees Celsius. That's too hot. STP is 0. 700 torrs. Your AP formula sheet actually relates torrs, so we can figure this part out. Look to your AP formula sheet. Backside, there's a section that says gases and liquids and solutions. In the right box, most of the way down, it says, about right here, 1 atmosphere equals 760 millimeters of mercury, which equals 760 torrs. So, however this relates, we're definitely not at STP. So back to our question, how do we figure out the volume of a gas that's not at STP? The ideal gas equation. So the first thing is these first 3 steps here are all the same because we have to figure out number of moles. So we're looking for moles of CO2, 0.00417. So let's look at all the different factors. We have a pressure, that's torrs. We are looking for volume. We have N, that's moles. We have T, although it needs to be in Kelvin. And R is on the formula sheet. So we're going to divide both sides by P because we want volume. Volume equals nRT over P. How much time do we have left? Oh, we're good. So let's look at our numbers one at a time. We have N is moles. Go ahead and put that one in here. 0.0417 moles. R. So we got our formula sheets out. R is the gas constant, and it's right above what we looked at earlier. Gas constant, comma R. There's about 50 different gas constants that I've seen. There's only 3 on this paper. Rather than changing pressure units, we have one here that relates torrs with everything else. That's the one we're going to use. 62.36, and its units are liters, torrs, per mole, per Kelvin. I know writing the units is a pain. It is a good habit. Temperature. I think it's on the same spot. Yeah. Look to the left side. The relationship between Kelvin and Celsius. We don't have to guess. If you're 100% confident, you don't have to look it up. But here's what it tells us. Kelvin equals degrees Celsius plus 273. And so our temperature here is 30 plus 273. And that'll be Kelvin. It ends up being just 303. Final thing, we have a pressure in torrs. There's no need to convert it because our gas constant said torrs. Now the reason I always favor using units in the equation is I can cancel things and make sure I actually did it right. So torrs is on top and bottom, gone. Let's see, moles and mole inverse, gone. Kelvin, gone. And look what we have left, just liters. And so we solve it. Here it is. 0.113 liters of CO2. And compare these two volumes. So we have knotted STP and we have STP. In terms of moles, these were the same moles. So it was 0.0933 here. Different conditions is 0.113. It has expanded a significant amount just based on temperature and pressure. See that? Let's stop there. I'll make a different video for number 8.